Okay, here is the final question on the paper. It is both about practicals and about magnetism. So it's quite a difficult question. A student placed a permanent magnet on top of a pan balance scale. He clamped a straight piece of wire so it's suspended in the magnetic field. When the current is passed through A to B, the reading and the balance increases. Explain why. It's a 4-mark question, so you have got 4 key points. This is all related to Fleming's left-hand rule and the equation F equals Bill. Force equals magnetic field strength times current times length. So first thing, the current creates a magnetic field. Okay, and the current is going from A to B, so it's going to be in that direction. So that is the magnetic field, circular magnetic field around the wire. That's going to interact with the permanent magnetic field. Okay. Then if we use Fleming's left-hand rule, we can figure out which way it's going. Zoom out for a second. Easiest thing I find is rotate your exam paper so you've got north, so you can just point straight forward. And then your current's going from A to B, so it's going to move up. So that whole thing there is going to experience a force upwards. So Fleming's left-hand rule. Says the wire moves upwards. That's 3 clear points then. So the wire's moving upwards, but it can't. It then forces the rest of it down. So that wire wants to move up, but as it can't, it forces what's below downwards. The force is still there. As this wire can't move, the magnets on the balance get pushed down, and that's what increases the balance reading. The student increases current on the wire. Sketch a graph to show the relationship between current and magnetic force. Well, because we're increasing the current, that's our independent variable. So we want to have our current, of course, in amps. Other side, magnetic force. Of course, magnetic force is in newtons. If we have no current, we will have no magnetic force. So it must be going through the origin. The length of wire in the magnetic field, figure 1, has that much length, that's L. Current reading is that much, that's I. Read reading is a mass, and we also have gravity. Well, those two together will give us force equals mass times gravity. And then we can work out the magnetic flux density, so F equals BIL. Need to rearrange that, so B equals F divided by I divided by L. 5-mark question here. There's lots and lots of things. It's 5 marks. We know we've got multiple equations. So first, let's work out the force. 1.2 times 10 to the minus 3 times 9.8, which gives us 0.01176. Then B is equals force divided by I divided by L, which is 0.01176 divided by 0.8 divided by 4.8 times 10 to the minus 2, which will give B 0.31. Just make sure you show all steps you're working out. If you do make a mistake, you can still get marks for error carried forward.